fixed number of trials, okay? So we're going to talk about two different probability distributions, so you can see that it's the geometric, and then the other one is going to be called the Poisson, okay? So, what does that mean? Discrete. Means that the random variable can be specific values, right? It can't be all fractions or decimals in a range, okay? So when you're creating your table, you know, just like you did before, 0, 1, 2, 3, 4, sometimes maybe you can have a 0, and we'll talk about that, but you're just going to list the values and write the probabilities next to them, okay? So it's not going to be that much different. And the formulas will be different, okay? Okay, now on a geometric, again, a trial, you don't have a fixed number of trials like you did when it was a binomial. Okay, what you do is you do a trial, which it could be flipping a coin, it could be shooting a basket, it could be calling for a date, okay? And you stop when you have success. And the chances, or the trial is repeated until you have success. Okay, the repeated trials are going to be independent of one another. Same kind of deal that we're making sure happens on the binomial. The probability of success is still P, and it is the same for each trial. Now here's the biggie. This is your random variable, X. Okay, and again, it doesn't stand for the number of successes. It stands for the trial where you have your first success. The number of the trial in which you have your first success. That's what X stands for. So on your notes, you can see that it talks about the problem at the bottom. So I'm not going to give you the formula yet. I'm just going to kind of go through the situation, and then we're going to help you understand the formula, okay, to understand the situation. But at the bottom, it says that basketball player LeBron James makes a free throw shot about 74% of the time. So that's his probability of success, okay? Find the probability that the first free throw shot LeBron makes occurs on the third or the fourth attempt. So if we were to make a probability distribution, remember that the X stands for the trial, in this case the shot, where he makes his first basket, his first free throw make. Now, you could have your first free throw make on the first shot. You could have your first make on the second shot, or the third shot, or any number of shots after that. It could be the 100th shot, okay? So the question is, what's the probability that his first make is on shot number 1, or shot number 2, or shot number 3, okay? So I'm not going to show you the formula. We're just going to kind of talk about it. What's this chance? 0.74. What's this chance? 1 minus 0.74, 0.26. So what's the chances that he makes it on shot number 1? Right. So that's easy. So let's keep on going on the branch where he missed his first shot. So if he misses his first shot, we still have 2 options on his second shot. So this is the second shot now. Again, either make or miss at 26% and 74%. So think of it like this. He missed the first and then made the second. Aren't we talking about 74% of 26% of the time? So a fraction of this 26, he's going to make it on the second try, right? So really all it is it's the probability of the first one being a miss times the probability of the second one being a make. So it's 26% times 74%. 0.19?
Yeah.
Let's go 3 decimals. What do you got for?
0.192.
Okay. Right? And then I think you can guess that probably the third one, he's going to miss it twice. And then he's going to make it on the third one. So miss, miss, make. So it's 75% of 26% of 26%. So again, symbolically, miss, miss, make. So if he makes it on his third attempt, he missed it on the first two. So you take the probability of a miss to the number of misses, and then he always has one make. So you take that probability 2 times the probability of made once, but it's always going to be 1 at the end. Okay, so probability-wise, we're going to say that this is about, boom. What are you going to do for 4? What do you think the chances of his first make being on the fourth one is?
Miss.
Right. So it's 0.26 to the third times 0.74. So that would be 0.013. So I think we kind of have a generalization here, don't we, for the formula?
So it says occurs on the third or fourth attempt. So do you add them together?
Right. So what's the chances that the first success happens on the third one or the fourth one? Is really what's going on here. So you're going to add these two together. So I would say that the answer to their question is 0.063. Okay. So let's go back and let's write the formula down. Let's talk about how we can do this on the calculator, and then I might throw one more thing at you as far as this problem goes. So the formula right here, I'm going to write it a little differently. I'm going to say that it's going to be Q, probability of a miss, how many times? X minus 1. Because if you're going to make it on the 5th trial, then you have to take the probability of a miss to the 4th times the probability of a make on that last make. Everybody understand that? Q to the x minus 1 times p. Okay? So let's switch to our calculator and let's have our calculator show us how to do it. All right, so your favorite button, distribution, a lot of stuff in there. But let's go up to geometric TDF. Or down, whichever way you want to go. 0.74. What's the chances that his first success is on the 3rd trial? Put a 3 in there. That should be the same as what we had. Okay. And then, again, shortcut, I would go second enter if we wanted to check what it would be for probability of his first success in the 4th trial. Just go back, change the value of x. Okay. So let me ask you this question. What would be the probability? I'm going to put another page here. What would be the probability that his first success is on the 4th trial or later? So he could conceivably make his first shot after missing the first 99 or missing the first 200. So that we got to figure out a different way of calculating the probability of an infinite number of trials.
Just do the 1 minus the other 3.
Right, so really, don't we want to add these probabilities up here? Well, we can calculate that probabilities by subtracting 1 minus those, right? Okay, so what was 3? point.
0.050.
Okay, you guys find 1. You guys find 2. Probability of 1 or 2 on your calculator. What did you get for 1 or 2?
1 is just 0.74.
Okay, yep, we knew that.
0.192.
Okay, so we already had that, I guess, didn't we?
Yeah.
Okay.
Housekeeping.
Okay, I didn't think where we were at. Okay, so this would be, I think this is about 93.2. 2, 14, 18, that's 0.982.
Yep.
So then this probability here is going to be 1 minus that probability. So that's going to be 0.018. So there's a 98% chance he's going to make it on the first, second, or third. What's the chances? There's going to be a 2% chance he'll make it after that. Okay. Anybody got a question on that? So again, let's make sure we understand. Binomial distribution, X stands for the number of successes in n trials. On a geometric, it stands for the trial of the first success. Okay, so your random variable is different. Okay, Poisson. Okay, again, it is a discrete probability distribution. Here's the key to tell you that it is a Poisson. You have to know the average number of occurrences. It could be, in this case, it's accidents. It could be the number of times that, I don't know, anything happens in a time period. So usually the interval is going to be like a time period, okay? So let me back up here. It's a discrete probability distribution. You can list them all, or you can start listing them all. It needs to satisfy the conditions that the experiment consists of counting the number of times an event. So the random variable X is the number of occurrences in an interval. And again, they say that the interval can be time, area, or volume. Usually it's time. The next thing they talk about there, the probability of the event occurring is the same for each interval. So down here, if they're saying that the average number of accidents per month is 3, then they're saying that the average for January and February and March and April and so forth are all the same. Okay. Now that's probably not the case in North Dakota, but maybe in this place or whatever it is. Okay. So the number of occurrences one interval is independent of the number of occurrences another interval. We got these independent probabilities going on. Okay. So in this problem, mu is 3. Now they use a different symbol on your calculator, and I think they do that because really it's a special kind of mean. It's like a mean per time. So they use a little different symbol, but you'll have to know the mean, whether it's symbolized that or that, doesn't matter. Okay. So in our formula, mu is 3. What is the probability that in any given month 4 accidents will occur? So if the average number of accidents is 3 in a time period, you can use this to calculate the average number or the probability that there's 4 accidents. Okay? So let's calculate that. So the probability that X is 4, right? When mu is 3. So this is going to be 3 to the 4th times E, Euler's number, that's what it's called, e to the negative, what's mu? 3, right? So negative 3 divided by x factorial, so divided by 4 factorial, which is 24. So punch that into your calculator. And we're not going to ever do this again. Okay? Because it's a lot easier on your calculator. But I do want you to do 1. Your E button is here. So it's going to be e to the negative 3, is that right?
But you have to put that parentheses, right?
That won't matter. No. And then as far as 4 factorial, that's 24. So I'm just going to divide by 24. So that's your probability of 4 crashes if you have an average number of 3 crashes. Okay. So let's go to your calculator and let's see if that ends up being the same thing using your distribution menu. So second distribution, Poisson PDF. There's your symbol, which in this case is, right, so that's 3, right? And then the x value, right, our random variable is the number of occurrences. 4. Now here's one thing here that I want to maybe talk about. You see, it won't let me go on until I have a value there. It will not allow me to go on because otherwise, if you don't put how many you calculate, there's an infinite number of probabilities to calculate, and it can't do that. Okay. Whereas binomial, there wasn't an infinite number. That's why you could list them all. Okay. So. Okay. And then again, if you wanted to change it and find the probability of 3 successes or 3 occurrences, you can go back and change that to a 3. You could go back and change it to a 2. Now that's kind of weird. This one makes sense to me because if the average number of occurrences is 3, then you should have it higher than 4, but it ends up being the same, 2 ends up being the same probability. That seems kind of weird to me. But actually what's happening is if I had to draw a picture of this, and I had, what's 1 probability? Can anybody calculate that for me?
0.1949.
149? Okay, so 149 is here. The next one is 224. Next one after that is 224. And then 168. But what kind of distribution do we have? Skewed. Right? So you got all these going out here. So where's the geometric balance point? Even if the geometric balance point is here, that doesn't mean that you can't have it weighted heavily on the other side of it. Could you have 0?
Yeah.
You bet. Calculate 0.
0.049.
Okay. So what if I asked you the probability that the number of accidents at this place are 3 or less? Well, you're going to add these up. And then you should be able to calculate the number of accidents that are 4 or more by using that. Should we do that? Let's do that. Let's do that real quick, okay? 0 was, again, 0.049.
0.814.
Okay. So we got probability that the number of occurrences is 3 or less is this, plus this, plus this. And you guys said that's 0.814. So the probability that there is going to be 4 or more accidents is going to be 1 minus that.
186.
So that's what you're working on. So go ahead and get working on that. Review Wednesday, review Thursday, test on Friday. Do a little activity. I got a little activity for you on one of those days.
Have you ever heard of game class?
Say what?
Have you ever heard of game class?
I haven't.
It is crazy.
You showed me how to play it.
I can't. It's like a board. I watched my dogs. My uncle's dog last night. And then I was like,
Is it in like the you play in a classroom?
It's crazy.
There's a gym game that like did these pretty blind. Okay, so it's like dodgeball, but you have a player and one of the partners is blindfolded. You can see that. And basically the other person just doesn't move. So it's pretty cool.
Okay, so we're in 3 Vegas here, and it's ball.
Two.
And you know Vegas too, there's a thing down the bottom, so you have to move that around to move that piece, and then move your part or your opponent.
So it's like
Now-
kind of like soccer with
It's-
magnets.
Yeah,
So
if you,
it doesn't move, right?
no, if you knock those little white pieces, if you put 2 on your opponent, then they get a point. No, you get a point, so then you wanna
And
knock
what
them
do
on
you mean
your
if you
opponent.
put it on your opponent?
If those things move,
Right, with the magnets, the white
yeah,
things do.
so, yeah, so if you like hit the ball and then it hits the white thing, and it attaches to your opponent, but
But
you
what
get
are
a point.